lesson 2-2, we will compare and order rational numbers. Remember, a rational number is any number that can be written as a ratio, which means a fraction. So we will replace the box or the dot with less than, greater than, or equal to make 3/7 blank 8/13 a true sentence. All right, so first thing I'm going to copy the problem here, 3/7 and then 8/13. All right. Well, in order to be able to compare these two, you would have to have a common denominator. And so to have a common denominator, the easiest way to do it is just to do 7 times 13 and get yourself a common denominator. But instead of going through all of that work, all we really need to do is we need to take 7 times 8, because again, if we do 7 times 13, whatever you do to the bottom, you have to do the top. Whatever you do to the denominator, you have to do the numerator, okay? And so 8 times 7 then is 56. And so then the same thing over here, we'd have to do 7 times 13. Whatever you do to the denominator, you have to do to the numerator. Okay, and so 13 times 3 would be 39. All right, and then all you got to do is compare these two numerators. So you don't actually have to rewrite the whole fraction. You just have to multiply the numerator by this denominator, because we would do the same thing here and then the same thing here. All right, but you don't have to actually calculate that. As long as you're kind of showing the work, you're good to go. Now you compare the 39 and the 56. Well, the 56 is bigger, and so we would say less than, and that would be your final answer. So this is your answer, but this is all your work that would be required to show on how to get that. All right, so same thing here. Let's copy the problem. Let's go 2/3, and then we'll go 3/5. Okay, just go ahead and show the work that we're multiplying by the denominator of the other fraction by 3, and then here we'll multiply by 5, which is the denominator of the other fraction. Okay, so all you have to do is the numerator, though, is 10, and this is 9. The 10 is bigger, and there you go. Okay, now I know you can do this in your head. You have to show me the step, show me the work, show me what you're doing, please. Okay, so all of this would be expected for what you show in your homework. Okay, where am I getting this 5? I'm getting it from right here. Where am I getting this 3? I'm getting it from right here. Okay, it's the opposite denominator, and that's what I'm multiplying by to compare them. Okay, replace the blank with less than, greater than, or equal to make -5/9 blank -7/9 a true sentence. All right, so let's copy it. We go -5/9, and we have -7/9. Now, since the denominators are the same, we compare the numerators right away. All right, what we were doing before is we were making the denominators the same. Okay, by doing this multiplication of 5, essentially we were multiplying 3 times 5 to get a denominator of 15. 3 times 5 to get a denominator of 15. We were making the denominators the same. That's what we were doing. Okay, here we were making the denominators the same. 13 times 7 is the same as 13 times 7. But now we already have 9 as the denominator. So we don't need to do anything else. All we need to do is compare -5 with -7. Okay, which one is bigger? Well, the -5 is greater because it's closest to 0. Okay, again, if we went on a number line here, okay, we have 0 right here. We'd say maybe we have -1 right here. Well, -5/9 is going to be, maybe just over halfway. Here's -5/9. And then -7/9 is going to be about right here, -7/9. Okay, so this one right here is closer to being a positive number, so therefore this one has a greater value. All right, so it says replace the less than, greater than, or equal sign to make 0.7 blank 7/11ths a true sentence. All right, so let's copy this down. We'll go 0.7 here, 0.7, and then we'll go 7/11ths. Oops, I'm sorry. Make that an 11, 7/11ths. All right. What we need to do is we need to get either this one into a decimal or this one into a fraction. Since denominators with 11, I know often end up being repeating decimals. I don't want to deal with that one, and this one is terminating, so I can easily get that into a fraction here. So I know this is the tenths place. That's the tenths place. So I can just say 7/10, and then I can say 7/11. Oh, I did it again. Okay, 7/11. Okay, so now same thing here. We need to make the denominators the same. So let's multiply this by 10. This would be by 10. Multiply this by 11. This would be by 11. So I end up with 77 over here, and I end up with 70 over here. So this one, 7/10, is actually greater. So this would be your answer again, but this is how you show all of your work. All right, we'll do another example like that. Okay, so let's copy it down. We'll go 0.4, and then we'll have 4/9. Okay, let's get this into a fraction. I would rather, take this to a fraction rather than take this to a decimal because of 9. I know it's going to be repeating. So we'll go with 4/10 because this is in tenths place, and then we have 4/9. Okay, so multiply by opposite denominators. So this is going to be times 9. This one's going to be times 10. Okay, notice now I'm starting to do maybe a little less and less. I'm not showing it down here because I know I'm not really doing anything down there. I just want to compare my numerators. Again, I'm getting the denominator from the number from the opposite denominator. So we have a 36 right here, and we have a 40 right here. So we would say less than. 4/10 is less than 4/9. All right, so replace the blank with a less than, greater than, or equal to make the sentence true. All right, so let's copy it. We'll go -4.62, and then we have -4.7. So it says graph the decimals on a number line. All right, if we were to have a number line here, we don't need a big giant number line. We just need from -4 all the way to maybe -5, and then you're going to need your halfway be -4.5. Okay, so then we're going to have -4.6. You're going to have your -4.7. Okay, now this might not be to scale, of course, but we just need to make sure we can compare these numbers. So -4.62 is going to be about here, and obviously -4.7 is right here. Now, which one is closer to being a positive number? It's going to be this -4.62. Okay, so do you have to graph it on a number line? No, but it helps you to see which one is furthest to the right. The one that's furthest to the right is bigger, is closer to being positive. The one that's furthest to the left is negative. So we want to figure out which one is closest to the right on the number line, which is going to be actually your smallest number. If you're comparing two negatives, you want the smallest absolute value. If you're comparing two negatives, you want the smallest absolute value. So this is a negative, this is a negative, so this one has the smallest absolute value. So we say that -4.62 is greater than -4.7. It's like saying I would rather owe someone $4.62 than $4.70. Okay. All right, the ride times for 5 amusement park attractions are shown in the table. Order the lengths from least to greatest. We want the smallest number first. All right, so we're looking up at this table here. 1 3/4, 1.5, 1.8, 2 1/12, 2.3 repeating. Okay, so I know that these two here are going to be the greatest. So basically I just need to compare these three and then get these two in order. Now, since this is 1 3/4, I can probably pretty easily get that into a decimal, saying 1.75. And then I see that the shortest time here is this double loop. So let's go ahead and write 1.5, and then we'll put a comma, and then we'll put 1 3/4. All right, it's important that when you're actually listing these in order from least to greatest, you put it in the original format of the number. So yes, I converted it to 1.75 so that way I could compare. But when I write it for my answer, I'm going to convert it into the original form. All right, so now I'm going to write 1.8. All right, so all three of these whole number ones are done. Now we have 2 1/12 and 2.3 repeating. So now I'm going to go ahead and compare those two. I'm going to say 1/12, and since this is a 3 repeating, I know that I'm going to get 3/9, or I can say 1/3 when I simplify. All right, so I'll use the 1/3 since it's a little bit easier then. Now we need to compare. So multiply this one by a 3 and multiply this one by a 12. Okay, so this is obviously going to leave me with a 3. This one's going to leave me with a 12. And obviously then the 12 is greater than the 3. Okay, so 1/3 or 0.3 repeating is going to be a larger number. So next we're going to say 2 1/12. And then we're going to say 2.3 repeating. Okay, so this would be how you want to show your answer. Okay, and all of this over here is kind of how you would show your work. Okay, so you could start by trying to answer the question, but then you want to maybe work some things out a little bit here so that way I can see it. All right, if you punch some things in a calculator that's fine, then just show me. If you were to take 2 1/12 and make it into a decimal, then just write 2 1/12, and then tell me what it equals as a decimal. Show me that you're doing something. All right, so you don't have to do everything by hand, but I need to see what you're doing to be able to compare these numbers, and then when you list them, please put them back into the original form of the number. All right, that's your last example for today. Be sure to check out Moodle page to find out your homework.